This video deals with slope fields. A slope field is just a tool we're going to use to help us figure out what the original function is given a differential equation. In our case here, we're given the differential equation dy dx is equal to x. And as you can see, I've got coordinates lined up for us to draw little line segments that represent the slope of the function at certain points. Drawing a slope field should not be too complicated if you notice certain patterns. In this case, we have dy dx is equal to x, so our slope will not be affected at all with whatever our y value is. In this case, I'm going to start out with x is equal to 1. When x is equal to 1, we're always going to get a slope of x, or 1 in this case. And all we need to do is, on our every coordinate where x is equal to 1, draw approximately a slope of 1 unit. Slopes do not necessarily have to be perfect. They really just need to be in the right direction and of approximate steepness. At x is equal to 2, we're going to have a slope of 2. So at every point where x is equal to 2 along that vertical line, draw a slope of x is equal to 2. At x is equal to 3, we're going to draw an even steeper slope, approximately. If you notice at x is equal to 0, our slope is going to be 0, so we just need to draw horizontal lines all along the vertical line x is equal to 0. X is equal to -1 produces slopes of -1 and steeper as we go along, steeper in a negative direction with our slopes as we go on to the left side of the axis. If you've done a slope field well, then you should be able to see a general pattern for what the original function looks like. As you should notice, this one looks like a quadratic. That makes sense because dy dx is equal to x, and going up and integrating will give us the function x squared over 2.